What is the CLiCC tool? In short, it is a web-based tool for assessing chemical life cycle environmental impacts, as well as human health and ecological risks. Our researchers developed the science that enables our tool and published those results in leading peer-reviewed journals. We believe that we have contributed to the advancement of science so that we can understand the behavior and impacts of chemicals better. In addition, we have collected massive amount of data and connected existing data sets through APIs. We have collected over 240,000 experimental toxicity data points covering 61,000 different chemicals, and we developed life cycle inventory data for 900 building block chemicals with which you can build your own life cycle inventory for your chemicals. We have collected climatic and environmental conditions over 10 years of time frame for 12 different representative locations around the globe. Finally, we have developed the computer programs that links science and the data and incorporated them into a web-based platform. Now, why did we start this long journey 5 years ago? First of all, chemicals are an essential component of modern lifestyle, but it is also important to recognize the potential harm that some of these chemicals may cause to the environment, human health, and the ecosystem. The problem is that we are creating new chemicals at an unprecedented rate. When we started our CLiCC program 5 years ago, I remember that the CAS registry just broke 100 million mark. 100 million. That is already a lot. But when I checked again recently, it has reached 140 million. Every day, we are adding about 25,000 new chemicals to the list. But unfortunately, the rate at which we can analyze and understand the life cycle environmental impacts and human health risks of these chemicals is much slower. This mismatch between the speed of chemical discovery and the speed of our LCA and risk assessment created a structural problem that will only deepen over time. This is not only an environmental problem, it is also an economic problem. Because LCA, animal testing, and risk assessments are not cheap, especially when they are multiplied by the increasing number of chemicals to be analyzed. Furthermore, producing or using chemicals without understanding their potential impacts can be a future liability issue. Finally, regulatory agencies also need a tool to assess the growing number of chemicals quickly and cost-effectively. So the question that we were facing was, how can we reduce the time and cost needed to understand the life cycle impacts and human health risks of chemicals? How we are addressing this daunting question? First, again, we believe that solid science is the foundation. As an academic institution, we cannot care less about scientific integrity. Science is not perfect, and there are still a lot of things that even the best science cannot explain or predict. We will continue to work on fundamental science to keep on improving our tool. Then it is really about data. As we talked about before, we have collected large amount of experimental data, and we are using APIs to connect existing data platforms on the internet. Next is the use of predictive tools. Our system prefers experimental data whenever they exist. But if there is no experimental data, then the system tries to estimate them using the best-in-class predictive tools, be them ensemble QSAR models or artificial intelligence applications. Finally, we take uncertainty very seriously. We run large-scale Monte Carlo simulation to provide the information on the distribution of the results so that users can make an informed decision. What is unique about CLiCC? First of all, it is easy to use, which is very important. It's a web-based platform. Anyone can just log in and start to navigate. Second, We are connecting a wide array of existing data sets. The amount of data that we have collected and connected is unprecedented. And we are using a lot of predictive tools to enrich our data system. And transparent methodology is also very important for us. Quantification of uncertainty, we take it very, very seriously. And I think it's also very important for us to consider not only just life cycle assessment or risk assessment in separation, but together for a better decision making. What can you do with CLiCC? There are three main groups of functionalities that CLiCC offers. First, it is about screening level chemical reports. Second, it is predictive life cycle assessment. And third one is human and ecological risk assessment. So when you go on to the website, www.click.net, you will see this page and you can already enter the chemical of your interest there. But you can log in using the link on the upper right corner. When you log in, you are asked to create a project, and then you are given the three choices that you are seeing here. The one is screening level analysis, and second one is life cycle assessment module, and third one is risk analysis module. When you choose the first one, which is the screening level analysis, then you have again three options under it. These are the three types of reports that can be generated under the screening level analysis module. The screening level scorecard, which I will show you briefly later, and the screening level chemical properties, and safety data sheet support. So it can generate the material safety data sheets. And if you choose the second module, life cycle assessment module, then again, there are two choices that you can make. One is life cycle inventory estimate, and the other one is life cycle impact assessment. Third one, risk assessment module. It has 5 modules, sub-modules there. One is chemical release module, chemical specific environmental concentrations module, which is basically fate and transport model. And then there are human health risk assessment module, ecological risk assessment module, and their combination there. This is a screenshot for the screening level analysis module, and we have a pre-populated 2 chemicals over there. So these 2 chemicals are dichloroethane and benzyl alcohol. Both of them are widely used as a paint stripper. As you can see that the complete button, which is you are seeing over here, if you can see my cursor over here, it says complete with a green checkbox. It means that the analysis has been done, already calculated, so that you can view the result. If you view the result, it will look like this. First, it provides the cradle to gate life cycle impacts using our predictive tool, machine learning algorithm, for both of those 2 chemicals. Please pay attention to the model confidence column here. So it shows using a simple bar representation how confident the model is in predicting these life cycle impacts. So it has cumulative energy demand, acidification, eco-indicator, and climate change, etc. And you can really see, what are the differences and trade-offs between these 2 different chemicals. It also provides hazard indicators, be them ecotoxicity and human health impacts. And as you can see, we have created in the middle, so for example, in the carcinogen question mark here, whether it's a carcinogen, then we say yes, and if it's not, it's no, and we have created a non-inconclusive in the middle following the advices of our partner. So again, you can see what are the differences, what are the trade-offs between these 2 different chemicals. So this is a screenshot for lifecycle inventory module, and currently we have not connected this parametric lifecycle inventory calculation. We are still working on that, but in principle, we let the users to choose the process parameters like the reaction efficiency, wastewater treatment efficiency, etc., so that you can generate your own lifecycle inventory based on the process conditions that you choose. And you can export the resulting lifecycle inventory to an Excel file and upload that to your preferred lifecycle assessment platform. Finally, this is the screenshot for the risk assessment module, and risk assessment is necessarily much more complex, as you can see, and there are more buttons down here. And of course, you can always override our estimates by your experimental data if you have. Human toxicity, ecological toxicity data, these are the modules that need to be run in order for the risk assessment to be completed. So once that is completed, then you can view the result like this. So for example, the risk assessment module can estimate the concentration over time. These are the number of days for San Francisco and Zurich. Those are the two global locations that we have already pre-populated in our data system. And you can see because of the rainfall, precipitation, and wind, there are fluctuations over time. And there is quite striking difference between these two geographies, as you can see. Beware that these are log scale, so there are quite significant difference between them. But the important thing here is that both of them are under the threshold. This is daily concentration in air. This is freshwater concentration. This is another, I think, concentration here. And this is a risk result. And we are comparing the risk assessment result of these two chemicals relative to the reference dose. And we can also view the breakdown of the exposure pathways. Finally, the uncertainty module allows you to see not only the deterministic value, but also the distribution of the result that we are generating. And it also further shows where are the main contributions coming from in terms of the uncertainty of the result. It seems that the daily intake from ingestion of exposed product for one of those chemicals, benzyl alcohol, is particularly uncertain, so that you can focus on refining those parameters that are pertinent to the estimation of this part in order to improve the overall uncertainty of your estimates. In summary, CLiCC tool offers the users three groups of main functionalities, and they are screening level reports, life cycle assessments, and risk assessment. And each of them are subject to uncertainty analysis shown here. Finally, a few words on our team and partners. The CLiCC project supported and nurtured next generation leaders, scientists, and environmental professionals, and many say that the experience under the CLiCC project has been critical in their career success. And not surprisingly, our researchers go out and have landed all kinds of awards. We are very proud of them. I thank our CLiCC team for their dedication and camaraderie that enabled us to arrive at this important juncture. Thank you. And I also thank all the partners for their generous support, without which we could not have achieved what we did. Thank you very much.